A hidden flaw beneath London's streets has let raw sewage spill into the River Thames more than 50 times a year, even after a £1 billion engineering legacy. The $5 billion super sewer under the river promises to turn this toxic tide at last, but the crisis runs deeper than most realise. What really pushed the city to dig a tunnel on this scale? And could it finally solve a problem that has plagued London since 1858? London's sewers trace their roots to the vision of Joseph Bazalgette, a civil engineer faced with a city in crisis. In the summer of 1858, the stench from untreated waste in the Thames grew so overpowering that Parliament was forced to shut its doors. That event, remembered as the Great Stink, pushed the city to act. Bazalgette's solution was a network of gravity-fed brick tunnels that ran beneath the streets, channeling both rainwater and household sewage away from homes and straight to the river's edge. At the time, this combined system made sense. By allowing stormwater and sewage to share the same pipes, the city could quickly clear waste from crowded neighbourhoods, using the river's tides to carry it away. London's population hovered under 4 million, and the scale of urban runoff was manageable. Bazalgette's design spared the city from deadly outbreaks and set a new standard for urban sanitation. But it also locked London into a system where stormwater and sewage would always travel side by side. Each time clouds gather over London, the city's underground network faces a test it was never built to pass. With every moderate downpour, the old sewers fill quickly, forcing a toxic mix of rainwater and raw sewage through overflow points and straight into the Thames. On average, this happens more than 50 times a year, sometimes after just a few millimeters of rain. The evidence is hard to ignore. Foamy slicks collect near riverbanks, and the sharp smell of sewage lingers near outfalls, even within sight of Parliament. For those who row, fish, or work on the river, these spills are not just statistics, they are a daily hazard. Oxygen levels in the water drop sharply after each overflow, leaving fish gasping at the surface and wiping out stretches of aquatic life. The river, once an open sewer in Bazalgette's day, still bears the scars of a system under pressure, with pollution visible after every storm. London's answer is a new tunnel running deep beneath the Thames. This purpose-built route is designed to intercept sewage overflows before they reach the river, carrying them eastward for proper treatment instead of letting them spill into the water. By diverting excess flows from dozens of overflow points across the city, the tunnel acts as a hidden safety net, capturing and conveying polluted water that once poured straight into the Thames. Its job is simple at heart. When the old sewers fill up during storms, the tunnel steps in, catching what the Victorian pipes cannot handle and transferring it safely away from the river. The project is not just an upgrade, it is a fundamental shift in how London manages its wastewater, aiming to protect the Thames for generations to come. This new system stands as the city's institutional response to a problem that has lingered for more than a century. Stretching for 25 kilometres beneath London, the Thames Tideway Tunnel is one of the largest wastewater tunnels ever built in Europe. Its main bore measures about 7 metres across, wide enough to fit 3 double-decker buses side by side. The tunnel threads through layers of clay and chalk, reaching depths of up to 65 metres below the city's busiest neighbourhoods. At this scale, the tunnel does not just move water, it acts as a vast reservoir. The entire system, when combined with the Lee Tunnel, can hold 1.6 million cubic metres of overflow, roughly the volume of 640 Olympic swimming pools. This storage gives the city a buffer during storms, buying time for treatment plants downstream to process what once would have poured unchecked into the river. The size of the tunnel is not just a feat of engineering, it is a direct response to the scale of London's challenge, built to intercept and contain the surges that overwhelm the Victorian network. During a heavy downpour, the system springs into action. Overflowing water from dozens of points along the old sewers is intercepted and directed down massive vertical shafts, some plunging more than 60 metres beneath the city. These drop shafts are engineered to handle the force and volume of surging flows, guiding the water into the deep tunnel below. Once inside, the tunnel acts as a temporary reservoir, holding polluted stormwater and sewage safely underground until treatment plants downstream are ready to process it. A Thames Water Operations Manager describes the process as a chain reaction. First, we capture the overflow, then drop it safely below ground, store it until the storm passes, and finally transfer it for treatment. Capture and transfer are simple words for a complex sequence that protects the river. At the tunnel's eastern end, powerful pumps at Abbey Mills move the flow onward to Beckton sewage treatment works, the largest in the UK, where it is cleaned before returning to the environment. The pumps at Abbey Mills are critical to moving stored flows onto treatment. Throughout this journey, sensors and control systems monitor every stage, and the Environment Agency provides oversight to ensure the tunnel delivers on its promise of a cleaner Thames. An agency scientist puts it simply: our job is to make sure the river stays protected, no matter the weather. At the heart of the project, tunnel boring machines, each the size of a 2-storey house, chewed through London's underbelly. These machines started their journey at riverside sites, where engineers worked in tight shifts around the clock. The ground beneath the city offered no guarantees. Some days the clay would crumble easily. On others, the chalk fought back, slowing progress to a crawl. One engineer recalls the pressure of guiding the cutter-head past a tangle of Victorian pipes, knowing a single misstep could flood a shaft or halt the entire drive. Each tunnel segment, cast off-site, arrived by barge along the Thames. Moving spoil by water kept thousands of trucks off city streets and eased the burden on neighbourhoods already hemmed in by traffic. At any given time, barges ferried away the earth as fast as the machines could dig, weaving between commuter ferries and pleasure boats. With 24 sites working in tandem, the logistics demanded constant coordination. One miscalculation and the whole operation could grind to a halt. For those underground, progress was measured in meters, but above ground, every meter meant another step closer to a cleaner river. Tunnelling beneath London was completed in 2024, closing a chapter on one of Europe's most ambitious engineering projects. By February 2025, all 34 overflow sites were connected, allowing the full system to begin intercepting sewage before it could reach the Thames. In the first months of operation, the tunnel diverted more than 7 million cubic metres of polluted water away from the river, a volume that would have otherwise poured through the city's outfalls during storms. As connections came online, the project's impact could finally be measured, not just in blueprints and promises, but in the sheer scale of water kept out of the river. A Tideway spokesperson said that with every connection, they are turning the tide on pollution that has blighted the Thames for generations. These milestones mark the transition from construction to a living system, one now tested with each rainfall and monitored for every cubic metre it captures. The tunnel's performance is no longer theoretical. It is written in millions of litres of sewage kept from the river, week after week. Independent reviews of the tunnel's first year point to a dramatic change. In a typical year, the system now prevents around 94 to 95% of sewage spills that once poured into the Thames. Where more than 50 overflows stained the river each year, that number has dropped to just a handful, mostly during the most severe storms. The tunnel's 1.6 million cubic metres of storage, combined with the Lee Tunnel, holds back the worst, but it is not a cure-all. Extended downpours lasting several days can still push the system past its limits, forcing some untreated water into the river. Environmental groups and academics caution that climate change and population growth may test this safety margin in the decades ahead. The cost, about £4.2 to £5 billion, will be paid by Thames Water customers, adding up to £25 a year to the average household bill. Regulators say this funding model spreads the burden fairly, but some campaigners argue that ongoing oversight is needed to ensure the tunnel delivers its promised benefits as conditions change. Today, London's river faces fewer overflows, but climate extremes and city growth keep pushing the limits. The Tideway Tunnel buys time, not immunity. Clean water is not a finished project. It is a daily choice, written in concrete, policy, and public will. The river's future still runs through us. Share your thoughts below.